Hello dear children, in today's class we will be having a discussion about the numericals from calorimetry. So first of all, when I say calorimetry only, many students they have a kind of a negative feeling towards the calorimetry chapter because the numerical seems to be a bit lengthy, okay, and we will be getting confused to when using the formulas. That's what most of the students they'll try to neglect this or else they'll try to do the last minute. And if last minute also, they'll do the only concept and they'll neglect the numerical. They'll think that, okay, if not this chapter, I go with some other chapter. Children, it should not be like that. Actually, calorimetry is the easiest chapter, but the approach is very important. How we are solving the numerical is important. So, every time I'll tell you, it is not just using the formulas, substituting the values and getting answer. No, it is not that. First, you should understand that numerical. Then, you should have idea about the formulas what you are going to use, and you should know in which situation what kind of formula to be used. That is a very important. So why many students will struggle with the numericals of calorimetry? First of all, lack of patience. With that, definitely they lose the interest. Obviously, they'll neglect this. So in today's class, maximum I'll try my level best. Okay, I'm not saying that 100% you do the 100% numericals from this chapter, children. After listening my class, if you have a good practice, definitely you do it. That is what I tell you. So it's not neither your parents nor your teachers. It is you children. At the end of the day, you. So you should be with you, right? So you are the one going to write the exam. So you should have a good practice. So definitely I'll try my level best to give you the concept so that you will get a complete idea to solve the numericals. Before that, you will get idea how to use and when to use the formulas. First, children, in a calorimetry, you should be clear with the units, whatever you are using, and the physical quantities, and to calculate those physical quantities, what kind of formulas which we are using. So, first you should focus on this. Children, in this chapter, first look at here, we will get a formula to calculate the heat. So, calorimetry is all about the heat, right? Yes. So, here we have Q is equal to mc delta T. Children, I will be telling you when to use a formula and all these things. But the thing is that listen the class, be ready with your notebook and a pen, try to take a notes. Okay, fine. Q is equal to mc delta V. So first see, forget about when we are going to use, what is the meaning. Just forget about that. Just let us list out. Q is equal to mc delta formula which we use. And also here C is called specific heat capacity. Specific capacity. It's a unit search, very important. Joule per kg Kelvin SI system, calorie per gram degree Kelvin CJ system. How these two are related also you must know that. That is 1 calorie per gram degree Celsius is equal to 4200 joule per kg Kelvin. And you can do the conversions accordingly. And we have a thermal capacity is equal to Q by delta T. This is the second formula. Children, the first formula which we are going to use, second formula which we are going to use. And we have a relation between C dash and C also. That is thermal capacity is equal to mass into specific heat capacity. Okay, fine. And for this units, children, for thermal capacity, SI units are joule per Kelvin and the CJS units are calorie per degree Celsius. Children, these units are very important. Most of the students they'll struggle with the numericals based on calorimeter. Sir, when we should consider the thermal capacity of calorimeter, when we should not consider, or else heat loss with the calorimeter or heat gain with the calorimeter. Yes, today I will give you clarity. Okay, so this is about the thermal capacity. And the third one which we have, Q is equal to ml. Here L is called what, children? Specific latent heat of fusion of ice. Generally specific latent heat actually. Okay, for this the SI units are joule per kg, CJS units are calorie per grams. So children, so these are the formulas which you should remember, and we also should know when to use and all these things. So let us solve small numericals, not a more number of numericals, hardly 4 to 5 numericals I'll explain you, then you will get a command. Okay, fine children. Now look at here. So for suppose here is a body of mass 500 grams. Okay now, okay, 500 grams. Okay, whose specific capacity, a specific capacity is given. For example, how much it is given? So let us take a 500 joule per kg Kelvin is given. Initially it is at a 5 degrees Celsius, 5 degrees Celsius, and to raise its temperature to 10 degrees Celsius, definitely we need to provide some heat. So how much heat should be provided? What is the heat required? Okay, children, look at here. Before that, let me give you clarity. You make it note, sir, here Q is equal to MC delta T formula we have, Q is equal to ML we have. Yes, children, both formulas are used for the same purpose, to calculate the heat only, either heat required, heat absorbed, or heat liberated. Heat absorbed or heat liberated. But when we should use Q is equal to MC delta T, when we should use Q is equal to ML is very important. First, let us get a command on the Q is equal to MC delta T. Children, this Q is equal to MC delta T is used only when there is a change in temperature. For suppose here, it's for example, here is water. So water at 10 degrees Celsius. So we want to heat Q, so that to raise its temperature to 30 degrees Celsius. So it is water, water. There is no change in state. There is change in temperature. Yes, here you apply MC delta T formula. Next case, here is ice at 0 degrees Celsius. We are heating. We are providing heat. Okay, then will convert into 0 degrees Celsius water. So it is ice, water. So there is a change in state, but there is no change in temperature. Here you can apply ML. That's it. Very simple. Children, Q is equal to MC delta T when there is a change in temperature. Q is equal to ML when there is no change in temperature, rather there is a change in the state. So in that case we should use. Okay, children, hope you got clarity. So this is a point where many students will struggle to use the formulas. Okay, fine. Now here, which formula should I use? So they are asking us to calculate the amount of heat required to what, to change the temperature of 500 grams of a body from 5 degrees Celsius to 10 degrees Celsius. Which formula? Q is equal to MC delta T, MC delta T. Now M is equal to 500, C is equal to 500. Change in temperature 10 minus 5 is 5 only. You do, but you get a wrong answer. Why? Sir, we are using correct formula, correct substitution, everything we did, but why we get a wrong answer? Children, here it is kg, but it is in grams. So this has to be converted. 500 grams is nothing but what, children? 500 by 1 by 2 kg. That is 0.5 kg. Okay, so you cannot use 500 grams, rather you can use 0.5 kg. This is 10 minus 5. So now it is, this will how much, children? 0.5 into 500, it is a 250 into 5. So this will be 0, 5, 12. So 1250 joules of heat is required. So this is how we can use Q is equal to MC delta T formula. Got it, children? Fine. Now look at here. One more formula let us take. Numerical 2, children. So here is body is given. Okay, so body of mass, so let us say it is a 2 kg is given. Body of mass, it is a 2 kg is given, and what we can say, it's a specific capacity, sorry, it's a specific capacity is given. C is equal to 1 calorie per gram degree Celsius, it is given. So what we can expect more? Q is equal to MC delta T, MC delta T, right? Okay, fine. So now if some heat is given to it, so that there is a rise in temperature of 10 degrees Celsius. Children, either rise in temperature, fall in temperature, we will denote with a delta T. Delta T is, it might be rise in temperature or fall in temperature also. So now in this case, they will ask us to calculate the specific capacity, sorry, thermal capacity. We have to calculate the thermal or heat capacity. Thermal or heat capacity. Thermal or heat capacity. Then how to do it? How to do it? Very simple. That formula which we have here. Okay, now don't go for C dash Q by delta T. Some children, they will try to calculate Q value delta T, not required, directly is there. So C dash is equal to mass into specific capacity. Mass is equal to 2 kg. Oh, here only again problem comes. It is in a grams, it is in a kg. Okay, let us convert this into 2000 grams. So this will be 2000 into 1. So this will be 2000 calorie per degree Celsius. Calorie per degree Celsius. Okay, children, fine. Now let us try to take one numerical where we can use these two formulas together. Okay, in a single numerical, we'll try to use this. Is this copied, children? Okay, fine. Now we are going to take one numerical so that you get idea how to use the both formulas together. So look at, children. This is ice. It is the ice. Okay. So let us take it the like 10 grams of ice. It is at a minus 5 degrees Celsius. So now we want to convert into water, which is at 100 degrees Celsius. 100 degrees Celsius. Then how much amount of heat is required to convert 10 grams of ice at a minus 5 degrees Celsius to 10 grams of water at 100 degrees Celsius. Now here we have two formulas. Q is equal to mc delta T. This formula we should use only when there is a change in temperature, but there is no change in state. But here if you can see, children, there is a change in temperature and as well as change in state. How to look at this numerical? Children, especially this kind of numericals only, we should have a patience. First of all, my question is that, do you think that ice at minus 5 degrees Celsius directly will convert into water at 100 degrees Celsius? That is a point where we have to think. What I mean to say that, do we get a stage ice minus 5 degrees Celsius to water 100 degrees Celsius? No, it won't happen. There are 3 to 4 stages are involved. Let us see that stages. First, children, the moment when you start heating ice, look at here. The moment when you start heating the ice, children, first minus 5 degrees Celsius ice will convert into 0 degrees Celsius ice. 0 degrees Celsius ice. Then slowly if you are heating 0 degrees Celsius ice to 0 degrees Celsius water we get. From 0 degrees Celsius water to now the temperature goes on increasing. It reaches 100 degrees Celsius water. So first you should understand this point, children. This point, what kind of state of changes are taking place. And no need to get confused here. Don't worry about the other values. All values will be given in the question. So specific capacity of ice is given as 0.5 calorie per gram degree Celsius. Specific capacity of water is 1 calorie per gram degree Celsius. Specific latent heat of fusion of ice is 80 calorie per gram. Mostly 99.999% values are given. If not, remember, because they are the standard values. Okay, fine, children. Now, children, so here the amount of heat required to convert minus 5 degrees Celsius ice to 0 degrees Celsius. Let us say it's a Q1. Let us say Q2. It's a Q3. Our idea is that individually we'll calculate Q1, Q2, Q3. Then we can add. Then we'll get the total amount of heat required to convert 10 grams of ice at minus 5 degrees Celsius to 10 grams of water at 100 degrees Celsius. Children, during the change of state, mass won't change. Right? It's very, very important. And during the change of state, temperature remains constant. Hence, kinetic energy remains constant. Only potential energy changes. This is an important conceptual question. Okay. Now, Q1, children, which formula should I take? Children, come on. For Q1, Q2, Q3, pause the video and tell me. Comment your answer. Q1, Q2, Q3, which formula should I use? MC delta T, ML. So for Q1, Q2, Q3, pause the video and just you text. Okay, comment your answer so that I will check. We'll check together. Okay, na? Paused. Okay, na? And done. Which formula should we use for Q1, Q2, Q3? Done. Chalo. Can we go? 1, 2, 3. Fine. Q1, children, there is no change in state. There is only change in temperature. So it is a MC delta T. But this is a ice specific capacity, ice. And Q2, there is no change in temperature, only change in state. So Q2 is equal to ML. Q3, There is no change in state, only change in temperature. It is mc delta T over. That's it, children. This is ice. This is water. That's it. Now you substitute the values, you get the answer. Can I erase this because we need space? Okay, na 3, 2, 1. Hope you have copied these three values. Okay, na? Fine. Look at, children. So mass is 10 grams. Specific capacity of ice is 0.5. Change in temperature. Here students will get doubt. Sir, -5, -0, no. Final temperature minus initial temperature. That is 0 of -5. So 10 into 5 is 5. This is 5 only. So this is 25 joules it is. Now here it will be mass is 10. For how much we have taken mass till? Okay, let us suppose 10 grams only. 10 grams. Okay. Specific latent heat of fusion of ice is 80. So this is 800 calorie per gram. 800 calorie per gram. 800 calorie per gram. And third one is 10 into specific capacity of water is 1. Delta T 100 minus 0, it is 100. So now 10 into 100, it is 1000 joules. Now the total heat required is, children, Q1 plus Q2 plus Q3. So this will be 25 plus 800 plus 1000. Children, if any calculation errors are there, just kindly check. 1825 joules, children. Children, numbers might be different in exam. Numbers, there might be change in the numbers, but not in a concept. So this is a concept. So I think, children, with this numerical, we get a complete idea when we should use Q is equal to MC delta T, when we should use Q is equal to ML. Children, Q is equal to MC delta T we should use only when there is a change in temperature, but there is no change in state. Whereas Q is equal to ML, we use only this formula only when there is a change in state, but there is no change in temperature. Now just copy this numerical. Now last, I will give you one more clarity. When students are solving the numericals based on calorimeter, so there is a confusion for a student. Sir, should we consider the heat gained or heat lost by the calorimeter or not? So how to know that? In some numericals, they are considering the heat gained or heat lost by the calorimeter. In some numericals, they are not considering. So I think some of you also might be having that confusion. Yes, today 100% I will give you the clarity so that you will get a command to solve the numericals based on even calorimeter also. Okay, just copy this first. It is a grams. Children, now we solve these two numericals. Now 100% you will get a command when solving the numericals based on calorimeter. Whether should we consider the heat lost or heat gained by the calorimeter? Yes or no? When we should consider, when we should not consider. So look at these two numericals. Now by seeing these two numericals, some student may get one doubt. Sir, everything is same. You wrote here, everything is same and you are saying two numericals. Yes. Have patience. Sometime. First let us try to understand this, children. This let us understand. Then this you will do it. And you will comment your answer also. I am very confident about it. First, children, what is the question, In a calorimeter, so I did not draw everything wooden box. Don't get confused. Only just copper. Just one taken. Okay. In a calorimeter, 150 grams of water is taken, which is at a temperature of 30 degrees Celsius. Now the question is that how much amount of mass of ice, how much amount of ice to be added to the water to bring the temperature of 30 degrees Celsius to 5 degrees Celsius. That is the question given. It's very clear that in this first we need to identify what is a hot body, what is a cold body. So many of you can tell that yes, sir, water is a hot body, ice is a cold body. Yes or no? Think, children. Think and comment. What is that? Here one more body also involved. What is that? Calorimeter. Also hot body. You may get one doubt. Sir, how can you say that calorimeter what is to be included in this question? Yes, children, look at here. It is given. Look at here. Thermal capacity is given. Children, in a numerical, if either thermal capacity or sometimes specific capacity and mass also given. Try to understand. Mass and even specific capacity of calorimeter also given. Both are same. If you multiply, you will get this. If it is given, then indirectly they are asking you to consider the heat lost by the calorimeter. If not, you have to neglect the heat lost by the calorimeter. Okay. First, children, here. So here hot body first we should identify. and is a cold body. Okay, now cold body is no doubt it is a ice only. Children, initial ice at a, try to understand, ice at a 0 degree Celsius. Okay, so that ice will be gaining the heat from the water and calorimeter together, right? Yes. So once it gets it absorb the heat, it will convert into water at 0 degree Celsius. Here children, very important. Already 150 grams of water is there. That is different here. Okay, na? And this water what? When ice melts, we get a water. That water, don't get confused. Here two waters are there. This water obtained from after melting of ice. Now this temperature also will be raised to 5 degrees Celsius, because the resultant temperature should be 5 degrees Celsius, means this water temperature should be 5 degrees only, and the water so obtained from this also should be at a 5 degrees Celsius only. So this is a from cold body side. Hot body side, here we have water, right? So here we have water. Okay, so initially it is at a 30 degrees Celsius. Okay, this has to be taken to 5 degrees Celsius. That is fine. And one more hot body is what, children? Yes, it is a vessel. It is a vessel. You may get one doubt. So then what is the initial velocity of the vessel? It is not given, children. As the water is taken in the vessel, so we expect that the temperature of water and a vessel is at the same temperature only, both in equilibrium. So yes, the vessel also initially 30 degrees Celsius only. It has to be taken to 5 degrees Celsius. Means on whole, final temperature should be 5 degrees Celsius. Okay, that's fine. Now what is our idea? Children, very simple. Heat lost, heat gain. You equate, you will get the answer. Here? Seriously? Yes, sure, not here, sure. Look at here. Children, it's very easy. First, children, now there is no change in state, the only change in temperature. So let us use Q1 is equal to MC delta T formula. MC delta T. So here Q1 is equal to what, children? Mass is how much? 150. Specific capacity is given how much? 4.2. Delta T, 30 minus 5, 25. So if you can simplify, how much you will get? Approximately, not approximately, 15,750. I remember the answer just before only I solved. Okay, 15,750 joules. This is a heat lost by the water to reach temperature from 30 to 5 degrees. Now heat lost by the calorimeter also. So MC delta T. MC delta T only. You make it out. Sir, mass and specific capacity is not given, sir. No problem. Thermal capacity is equal to mass into specific capacity. Thermal capacity value is given. So that is 40 into 25. So this will be how much? 1000 joules. So this is completely heat loss, children. So here heat lost is equal to Q1 plus Q2. So that is 15,750 plus 1000. So this will be 16,750 joules. Children, this is a heat lost. But together, water and a vessel. Why we are considering the vessel? Because in the value is given. Whenever either specific capacity or thermal capacity of the vessel is given, children, you must consider the heat lost by that vessel also, or heat gained by that vessel also. Clear? Fine. Now another side, children. Another side. Now look at here. Can I erase this? Can I erase this diagram? Can I erase it? Can I erase? Yes. Because we need a space. We need a space to do it, right? Okay. Now here, there is no change in state. Okay. Let us say Q3. We have to use ML. So mass is not known. L is given how much, children? 336 joule per gram. Okay. Now, so 336 M only it is. Leave it. Now Q4 is equal to MC delta T. Why we are using MC delta T? Change in temperature, no change in state. So mass is given, not known. Specific capacity of water is given 4.2. Change in temperature 5 minus 0, it is 5 only. So if you multiply 5 2s are 42, right? So this is 21 M. This is 336 M. Now heat gained by ice is how much, children? You have to add Q3 plus Q4. Q3 plus Q4. So this will be 336 plus 336 m plus 21 m. So this will be how much, children? Just check the calculation part. Sometimes I also might go wrong. Okay, kindly check concept. So this is 753 joules. This is a joules. So now, as per the principle of calorimetry, so we are neglecting the heat loss in the surroundings. Heat lost by the hot body equal to heat gain by the cold body. So heat lost or heat gain, no, anything is okay. So heat gain must be equal to heat lost. So heat gain is what, children? 357 into m is equal to heat loss 16,750. So mass is equal to 16,750 by 357. Come on, do it. So this is 46.92 grams of ice, children. So this much amount of ice is required. Are you able to see the 46 point? Yes. So children, this much amount of ice is required to bring the temperature of 150 grams of water from 30 degrees Celsius to 5 degrees Celsius. But the thing is that here we considered the heat loss by the vessel, that is the calorimeter. Why we consider? Because your thermal capacity is given. In some other questions, they may give you mass and specific capacity. You multiply both. Same thing, children, here. MC delta T means, if for example here thermal capacity is not given, they might have given mass and specific capacity. You substitute, you will get it. If either thermal capacity or specific capacity of the vessel is not given, then no need to consider the heat lost. Now that is the numerical which we are going to do it also. Now, is it copied, children? 3, 2, 1. Children, now look at here. This numerical, now I am not going to do it. I am not going to. Can you try this? Don't consider, because here only specific capacity of water is given, a specific latent heat of fusion of ice is given. But either specific capacity of vessel or thermal capacity of vessel is not given, which means what? Indirectly, they are asking us to neglect. Children, in some numerical, they only will tell neglect the heat loss with the calorimeter or heat loss with the vessel. No problem, no headache. But if they don't mention, if they don't mention that neglect the heat loss or heat gain by the vessel, then you should be very careful. You should see either specific heat capacity or thermal capacity of the vessel should be given. If it is given means, yes, you should consider the heat loss or heat gain. If it is not given, no need to consider. Children, now same numerical, here they did not give in this numerical, specific capacity is not given. Then what we have to do? Look at here. This we should neglect. So this won't be there. Look at here, very simple, this won't be there. Now look at here. Now how the numerical is going to be changed? Look at here, simple. So this is a heat loss, that's it. So now heat gain is equal to heat lost. So heat gain is how much, children? 357 into m is equal to heat lost 15750. Now mass is equal to how much, children? 15750 by 357. This is a grams. Just you simplify this, that will be the answer. That's it, over. That's what I said, 2 numericals, children. Hope you got clarity, children. So don't get confused. Once again go through these 2 numericals. So we have solved 2 identical numericals, but small difference is there. In the first numerical, thermal capacity of vessel is given. That's what we consider the heat lost by the thermal vessel. But in this, just I erased, which means what? We no need to consider the heat lost by the vessel. Why? Either thermal capacity or specific capacity is not given. Is it clear, children? So these are the numericals. I cannot say that we covered all numericals, children. Models we covered. Whatever the important, little bit complicated type what we can say models are there, just we tried. Especially, see, I have seen many students that are struggling to solve these kind of numericals, where should we consider the heat loss with the vessel or not. I think with this you get a command, I feel. Okay, children. So just go through the concepts, practice the numericals, get command. Just what are the exams which you are going to face, pre-finals and annual examinations, prepare for those exams very well, write the exams very well, get the results in a well manner. Okay, children, thank you so much, all the very best.